This is a pretty impressive crowd for a pretty important cause. And this week, last couple of weeks at the hospital have been a little bit of a rough for our team. And we never get used to it. And the reason we never get used to it goes to sort of the comment that Terry had made, and I think it is that we are here, and we meaning my colleagues across the country and around the world, we are here to finish what he started. And we are still a fairly long way away from that, notwithstanding the positive story. So, but in spite of some of the troubles we had this week, we also had some inspiration. And just actually yesterday, one of my relatively new patients, who's about 15 years old, has the same tumor as Terry, an osteosarcoma. And it's a tale of two stories here. So a little bit younger than Terry was when he was diagnosed. Also an athlete, played AAA hockey before his tumor. And inspired once we told him what was going to happen, that he was going to get treatment, that he was going to get chemotherapy and surgery, that while he would not play hockey at the sort of level he was, he said, but I will play hockey. And I said, well, he said, I'll play sledge hockey. And I said, that's good. How do you know that? And he said, because Dr. Malkin, one of your former patients is on Canada's national sledge hockey team, and I'm going to be his teammate. So, and he's right. Adam Dixon was a former patient of mine, and he was on, or is on, Canada's Olympic sledge hockey team. And nothing held him back while he was undergoing treatment. Nothing held him back now. And his picture's been in the newspapers coming up to the last Winter Olympics, and he likes telling his story. He was also a bit of a rebel, because we always told him that while he had all this metal in his leg, he wasn't supposed to be running around and doing things. And he said, with you, I'm going to run around and do things. And he had all sorts of broken metal screws and things in his leg, and was frequently at the hospital getting hardware repaired. But, you know, whatever. So today, one of the challenges, though, the second part of that story is that my young new patient will receive essentially the same treatment that Terry did. And the likelihood of survival is, unfortunately, 35 years later, almost exactly the same. So in spite of all the progress we've made in many, many ways, and I'm going to talk about that in a second, there are some tumors for which we really still haven't figured out how to treat them better. And that's why we do research. And that's why you're running for research, and that's why you're running for the kids and the adults for whom we need to find better cures, more effective cures, cures that don't make you sicker than you were when you started the disease, and that we don't feel we have to bring someone to the edge and just hope that they don't fall over, that we can pull them back. And that is what this is all about. So 80% of children with cancer are cured today. It's actually about 82% if you're counting. That compared to when I started my practice, well, when I started my residency about 25 years ago now, has doubled. It was about 40%. So in one generation, a doubling in survival of childhood cancer. Okay. In fact, children with leukemia, the more common types of childhood leukemia, basically now have an almost 98 to 99% likelihood of being cured, which is like, and to that point, and getting to this issue of pushing to the edge and coming back, is some of the patients that I had treated early when I started received radiation to protect their brain and their spinal cord from leukemia cells coming in. And that, in a young child, you can imagine can cause quite a lot of damage. So while we were curing many of those kids back then, they grew up with quite significant developmental challenges from the radiation. So it was, we won the war, well, we won the battle, but perhaps didn't entirely win the war. Nowadays, we're getting those 98% cures with no use of radiation. There's no radiation involved. It's all chemotherapy. And the reason we know that we can do that now is because of research. So over the last 25 years, clinical trials, studies were done gradually eliminating radiation in large portions of those patients, and then smaller ones and smaller ones. You got to the point where you could adjust the recipe in other ways and get rid of one of the most toxic ways of treating cancer. It was very nice. So what about Canada? Terry Fox is Canadian. We're Canadian. Why are we so great at cancer research? And we are. We in Canada are one of the leading countries in progress for understanding cancer, for treating cancer, and looking forward to a better future. And in Ontario, where we're sort of represented here, there are many projects supported by the Terry Fox Foundation, Terry Fox Research Institute, and I'll just touch on 3 of them because they are exciting. They're all exciting, but these are really exciting. So there's a guy in Ottawa by the name of John Bell, who some of you may have heard of. And he came up with an idea, crazy idea. That's the whole thing about what we do. You got to be a little bit crazy. And when you're a little bit crazy, you come up with crazy ideas. And a crazy idea is only a crazy idea if the next morning you wake up and realize it was a crazy idea. But if the next morning you wake up and say, actually, that's a pretty interesting idea, then it becomes something that you grasp and you move forward with. On a total aside about that kind of thing, anybody know how Paul McCartney wrote Yesterday? He dreamt it. And he woke up the next morning and he could do the whole thing. And then he knew it was a hit. So that, because he still doesn't know how to read music. So that is how science works as well. You come up with ideas, and if the next day they're still good ideas, then we run with them. So John Bell came up with the idea that maybe viruses would be useful at killing cancer cells. And so he's been working for the last 20 years in developing essentially what amounts to a vaccine, not to protect you from developing cancer, but for attacking cancer cells. And these viruses are called reoviruses. They're sort of like the cold virus, actually, but they've been manipulated. And he's now demonstrated very effectively that in quite a large number of tumors that are resistant to other forms of treatment, that treating them with this virus basically just destroys them. The cancer cells just basically erupt and are destroyed. And you'd say, oh, that's kind of cool, that's interesting, so what? Well, the so what is actually there's now clinical trials using that. So now patients are actually receiving that. This is no longer just stuff that's going into mice and into cells in a petri dish. This is actually humans like you and I who are now receiving these viruses. And these trials are now are being developed and being utilized all around the world, and they started in Ottawa. The second major area is in what we call precision medicine. Precision medicine. So the idea there is it used to be, and it still is to a degree, that if somebody has breast cancer, they get treated with this particular cocktail of drugs, radiation, surgery. If they have this type of brain tumor, they're treated with a different cocktail of drugs, radiation, surgery. If they have leukemia, they're treated with a different cocktail, and so on. Every tumor group seems to have a different treatment. And all of these drugs are to better or less effective at killing the cancer cells, but they also destroy or damage a lot of normal cells and all the side effects that go along with that. So over the last about 6 or 7 years, this is really recent history, we now have the capability that we can take a tumor or a tumor cell from an individual patient. We can sequence, we can map out the letters of its DNA, which is different than the normal cell's DNA by definition. It's a cancer cell, it has bad DNA. And we can identify from that DNA signature what we call markers, or what we call sort of like almost a telltale sign that codes for a protein, and that protein we can then take a drug to attack. And that protein on the cancer cell is abnormal because it's a cancer cell, and it's not found on any other cells in the body. So that what happens is you can take a precise abnormality in a cancer cell, treat it with a precise drug so that it kills the cancer cell and spares all the rest of the cells in the body. You say, okay, this is like, okay, fine, sounds lots of sciencey goobly-goop. In fact, one of my patients now, who's 6 years old, who has been resistant, she's relapsed now five times. Same sort of inspiration and determination that Terry had, however. She ain't given up yet, nor are her parents. So we sequenced her tumor using this high-tech stuff. And it turns out that she has an alteration of a gene that was completely unanticipated. There was no reason for us to have believed that this particular gene was going to be abnormal in this particular girl's tumor. But it was. And it turns out that there's a drug that we would have had no reason to use otherwise, because it didn't fit all the traditional ways of doing it. And so we said, all right, let's contact the drug company, which is another story, and see if we can get this drug for this patient, precision medicine. And explained all the rationale for it. And they accepted the rationale, and they provided the drug. It's expensive, and she's responding. Okay? There are now clinical trials starting. There are individuals, patients being treated all around North America, Canada, the world on this thing. It's a rising tide of expectations and excitement. This is going to be the new way that we treat cancer and probably other diseases as well. And we're at the forefront of an entirely new concept of thinking of how cancer can be beaten and how cancer cells can be destroyed and how we can spare the rest of the body from that. It's an exciting time at last for us to live in, because for the last 25 years, it's been the kind of the same old drugs using grandma's recipe to just mix them up a little bit, but at the end of the day, not making as much progress as we want. So we hope and we expect that over the next few years, with Terry Fox support and your support, these individual success stories will become the norm. And the reason that's important is because it still means 80% of children with cancer are cured, which means 20% are not. And until we make that 20% zero, and until we make the 40% of adults with cancer who are not cured zero, we have not achieved Terry's dream. And that's why you're here. So I'm going to be on the run next September. In fact, my wife and I are going on our, not our honeymoon, 25th anniversary thing. What do you call it? Trip. Boy, I'm happy she didn't hear that. Yeah, right. Anyway, it's a great ship. I came up with the idea, and she's going along with it. We're coming back the day before on Saturday. I'm sure we'll be ridiculously jet-lagged, but that's okay, because Terry Fox was far more than jet-lagged when he ran a marathon a day. I'll finish, though, with two other small pieces then. The research community in Canada is diverse. It's explosive. It's exciting. There's people like Dr. Bell. There's Michael Taylor in Toronto, who's developed a whole new way of understanding and treating childhood brain tumors. There's Uri Tabori, happens to also be in Toronto, who's discovered a whole new type of way that cancer develops genetically. There's Dr. Joe Connors in Vancouver, who has basically changed the way we treat in the world lymphoma, one of the most common types of tumors. Pam Goodwin and others in Toronto who have a better understanding of breast cancer and made it basically a curable disease for most now women. And then also a recent Order of Canada recipient who also has discovered our understanding of lung cancer. So these things are Canadian, and we've got to be proud of what we do. And the pride that I found, again, twice in the last year was there's a Terry Fox Science meeting that we have each year in May, where all the scientists get together and we talk about our research with each other, and the new trainees and new young people come and hopefully get inspired. But what is most inspiring is we get up at 5:30 in the morning. We did last year, it was in St. John's, and a whole pile of all of the scientists and researchers get up at 5 in the morning. It was actually snowing in the middle of May in St. John's, and we ran down to the, for about, I think it was a 6-kilometer run, ran down to the statue at St. John's where Terry stepped into the water, turned around there and came back uphill. And then to make it just a duplicate, we did the same thing in Vancouver this past year. And the intent was, of course, that was where he was going to end his run, which, of course, he didn't. And that's why these meetings on the 35th and 36th anniversary were where they were. And again, everybody, all these scientists, doing what they do, got up early in the morning, ran the run that he was going to run in Vancouver, and turned around at the sleeping dog and came back uphill. It is an uphill battle, but I can assure you that very soon it will be downhill all the way.